in previous lecture, we were doing a method of images. So in this lecture also, I'm going to continue with the discussions on the same. Okay. So okay. So we were doing a method of images only. So here also I'm going to discuss some of the concepts, and let us take one other concept, and that is also quite important. And we'll see all these cases in greater detail also, but right now we're going to do a few problems. See, till now we have considered the cases where we have taken only a single, you can say a single infinite line of sheet. Now, what if there is a intersection of two lines, infinite line of a grounded infinite line of infinite, you can say grounded infinite sheets. So if you have, let's say, the first case that I want to discuss is, let us say, a case of two orthogonally.
सर
हाँ जी बेटा बोलो. अच्छा सॉरी
सर डाइपोल वाले केस में अगर हम डाइपोल इनफाइनाइट प्लेन के पैरेलल ले लें तो क्या वो क्या कॉम्प्लिकेटेड प्रॉब्लम हो जाएगी?
नहीं कॉम्प्लिकेट नहीं होगी प्रॉब्ली. लेट मी थिंक ओवर इट ना, एक बार समझ लो तो ना, मतलब तुम ये कहने की कोशिश करो अगर ये डाइपोल ऐसे नहीं और किसी एंगल पे प्लेस कर दें या प्रॉब्ली एट
यस सर.
पैरेलल साइड में. लेट मी थिंक अपॉन इट, एक बार सोचने दो मुझे उस पर ना, एक बार सोच के फिर मैं जवाब दूं. इज दैट फाइन? विल डू दैट
जी सर.
प्रॉब्लम सो अगर ऐसा है तो स्टार्ट लेट. ओके.
सर आई वांट टू ट्राई.
ओके दैट आई ट्राई. ओके. नाउ एक काम करते हैं, लेट अस टेक द केस ऑफ ऑर्थोगोनली intersecting. Orthogonal means at 90 degrees. Intersecting infinite grounded conducting planes. So if I have this, let's say this is my infinite grounded conducting plane point number 1, and this is another infinite grounded conducting plane. Okay. Now if I place a charge Q, here at a point A, B, let us keep it general, then how things would transpire. So one has to understand one of the formulas from your standard 10 comes handy here, that number of images. I'm not very sure of how this formula is derived, that I need to see when I'll do ray optics. But right now, let us use this formula as it is. And it is equals to 360 degrees divided by whatever theta in degrees is given minus 1. So these many amount of images are formed if you have two intersecting mirrors. So it is intersecting at 90 degrees. So the answer would be 94 minus 1, 3. So there should be 3 image charges. This is one thing that one can understand. And from slight understanding, one can understand that if I want to replace this entire problem by line of, like by assuming some image charges, so what should be the location of it? So because of this particular, you can say infinite grounded conducting plane, this charge Q is there, so there would be minus Q here. So this minus Q would anyway make this particular potential 0 here. Because of this charge Q and because of this infinite grounded conducting plane, there would be a potential 0. So in order to make the potential 0, I need a minus Q here. But still, you can see that there is a possibility of potential, let's say, at this origin. So what I'll do, I'll exactly keep a charge minus, I'll exactly keep a charge plus Q here, so that if at origin, if I have this electric field due to this in this direction, I should have an electric field in this direction. So all these 3 point charges should be there, because I have already told you that total number of image charges that should be generated because of the placement of this charge is 3. And what should be the placement? 1, that Q is here, so minus Q should be here. 1, that Q is here, minus Q is here. So all the problems are solved, but at origin you can see that there would be again some potential. And in order to negate this potential, you can say that negate this potential, one has to like, again, the problem is of charge, negative and positive, right? So another problem. So one has to see equity. Okay, let me see the problem. So case of two orthogonally intersecting infinite boundary plane. हाँ ठीक है. So देखो चार्ज क्यू कारण माइनस क्यू यहाँ आएगा, चार्ज क्यू कारण माइनस क्यू यहाँ आएगा, and okay, so one has to see that boundary, one has to have this to q to q. Okay. So another thing that one needs to see is that total. So one has to see एक काम करते हैं. Okay, okay. So one can understand, let's say, one can understand from this. So let us say, I should make a boundary here. एक बार एक समझने की कोशिश करते हैं कि वो क्या रहा है. Let us try to make a boundary over here. Is that clear? So this is my boundary. Okay, and if this is my boundary, one has to understand that because of this charge Q on this conducting plane, there would be equal and opposite total charge induced. So total charge induced on this and on this should be equal to what? Minus Q. Is that clear? So this is your total charge induced. Is that clear?
Yes, sir.
So within this boundary, the net charge must be zero. Okay. So within this, because I was actually expecting, whatever I was explaining for field, but we have to understand it as a potential problem at first. So net charge must be zero within this boundary. And whatever thing I do, like even if I replace this problem by image charges, the condition that the boundary should contain a net charge zero should also remain intact, right? Because हमने mathematically problem को change जरूर कर दिया, लेकिन हमारी boundary conditions तो change नहीं होनी चाहिए. So within this boundary, again my net charge must be zero.
Right, sir.
है ना? So obviously one can understand कि ये Q का तो समझ में आ रहा है कि इमेज आपने माइनस क्यू बना दिया, ये Q का आपने एक इमेज चार्ज माइनस क्यू बना दिया, बट why this Q? Why not minus Q? Because actually I was दिमाग मेरा काम नहीं किया एकदम से, मैं सोच रहा था कि फील्ड, फिर याद आया फील्ड थोड़ी देखना, वो तो पोटेंशियल देखना है ना इस पॉइंट पे, तो पोटेंशियल तो स्केलर क्वांटिटी होती है, वो उसका कोई डायरेक्शन से थोड़ी लेना देना. So probably the reason why this Q is placed here, one can think that total charge must be zero within this boundary. So this is your boundary condition. So your total charge would be zero only if I place Q here. If I place minus Q here, then this minus Q would be minus 3Q, and Q, the total charge within this boundary would be minus 2Q, and that changes our boundary assumption. Is that clear?
Yes, sir.
Okay. So let us place this charge Q. So this is at A comma B. This could be at A comma minus B. This would be at minus A comma B, and this would be at minus A comma minus B. Is that clear? So I'll again redraw this figure here. So what one wants to find, what is the force, on charge Q. So we want to find the force on charge Q. Due to this arrangement, okay, so this arrangement. So this is my charge Q. This is placed at so because of minus Q, it will feel a force here. Because of minus Q, again it will feel a force here. And because of Q, it will feel a force in this direction. Okay. So in totality, this charge Q is subjected to three forces. One is this. This will be, I think, K Q square divided by, I think, 4B square. And this will be, I think, in the direction minus J cap, if I consider this as XY plane. Another force that it would be subjected to will be in this direction. This is, I think, K Q square divided by 4A square minus IQ. Is that clear? another force it will be subjected to will be in this direction. This will be k q square, and if this is, let's say, what should I say? If this is, let's say, to B, and let's say this is to A, then this distance would be root over 2A का whole square plus 2B का square. So KQ square upon 4 A square plus B square in this direction. So obviously there would be some component in this direction, some component in this direction. Okay, is that clear? And this is 45 degrees. One can find the components and one can find the net force. Is that clear or not? I think this is
Yes,
something
sir.
that you can do on your own, right? So the net force, I'll do it. So net force would be KQ square upon 4 root 2 A square plus B square minus KQ square upon 4B square J cap, and again plus KQ square upon 4 A square plus B square, again cos 45. This will be again 1 upon root 2 minus KQ square upon 4A square. This will be okay. So this is the net force that it would be subjected to. This charge Q will be subjected. Is that clear?
Yes, sir.
Okay. अच्छा, एक और दिक्कत होगी ना, ये 45 तो तब होता जब हमें डिस्टेंस इक्वल दे रखी थी, राइट? ये तो स्क्वायर वाला केस थोड़ी हुआ. सो आई शुड राइट इंस्टेड ऑफ 1 by root 2 आई शुड राइट cos थीटा, राइट? दैट वुड बी बेटर थिंग. आई शुड राइट cos थीटा. सॉरी, बिकॉज यहाँ तो अपना रेक्टेंगल जैसा कुछ हो गया ना. ए इक्वल टू बी होता तो हमारा बिल्कुल एग्जैक्ट बाइसेक्शन से निकलता है, मतलब,
Yes, sir.
है ना? अगर स्क्वायर होता तो ये बाइसेक्ट करता ना एक दूसरे को, अगर स्क्वायर नहीं होता तो नहीं. तो आई वुड राइट, आई थिंक cos थीटा शुड राइट. इट वुड बी बेटर थिंग टू राइट cos थीटा. बेटर नहीं, मतलब यहाँ तो cos थीटा ही होगा. आई शुड राइट थीटा हियर. I should write theta here. So total in this direction would be k q square upon 4 a square plus b square cos theta, and here also it would be kq square upon 4 times a square plus b square cos theta. Is that clear? है ना?
Yes,
और
sir.
cos theta क्या होगा चेक करें हम लोग. So let's say this is your theta, और ये डिस्टेंस, ये q जो है वो कहाँ प्लेस्ड है? At a comma b. So this is like a, this is b, तो ये हो जाएगा b. This will be I think root over a square plus b square if I'm not wrong. So एक काम करते हैं, इसको ढंग से लिख लेते हैं. So this will be cos theta would be a upon something. So I'll write k q square upon 4 a square plus b square. Again I should write a upon root over a square plus b square minus kq square upon 4b square j cap. This is 1, and plus kq square upon 4 a square plus b square. Again it would be a upon, again I think this is a होगा, क्या होगा, एक वापस चेक करते हैं. If this is theta, this will be 90 minus theta, right? This will be 90 minus theta. And if it is 90 minus theta, this would be sin theta. Sorry. ठीक है, तो sin theta लिखना चाहिए मुझे. ठीक है, this should be cos theta. That is absolutely fine. This will be sin theta. है ना? सॉरी, है ना? गलत समझ में आ गई ना मेरी बात? मैं क्या कहने की कोशिश कर रहा हूँ? देखो, अगर स्क्वायर
Yes,
होता है
sir.
ना तो डायगोनल बाइसेक्ट कर जाता है. Because this is not a square kind of case, because here you have distance 2b and 2a. So you'll have to take angle here. So theta अगर मैं मान लेता हूँ, so इसको ढंग से कर लेते हैं. So j कैप में sin theta आएगा, sin theta में I think b आ जाएगा यहाँ पर, और cos theta में a आ जाएगा. Is that clear?
Yes, sir.
थोड़ा सा पहले ढंग से कर लेता हूँ. ठीक है, पर कोई बात नहीं, हो गया जो गया. ठीक है, so this is IQ. Is that clear? So this is something that you're going to get. Is that clear?
हाँ जी सर. सर इस प्रॉब्लम को हम ऐसे भी अप्रोच कर सकते हैं जैसे कि हम ये इसमें मोनोपोल कंट्रीब्यूशन 0 है और डाइपोल कंट्रीब्यूशन
हाँ
0.
that also.
पोटेंशियल क्वाड्रुपल आइटम है कि फिर उससे फील्ड और फिर फोर्स.
बिल्कुल उससे भी कर सकते, कोई इशू, क्योंकि इसका टोटल चार्ज तो 0 आ ही रहा है. And it is like uh, two equally and opposing dipoles here.
Yes, sir.
Okay, that also you can. That is not much. But keep a care of all these things, because यहीं पे गलतियां होती है एग्जाम में. ठीक है, तो जल्दीबाजी नहीं करनी, मैंने कर दी, बट somehow अंडरस्टैंड कि यहाँ पर ही स्क्वायर नहीं है, स्क्वायर होता तो 45 डिग्री से, समझ लो। अगर ये डिस्टेंस a कॉमा b की जगह l कॉमा l दे रखी होती, मतलब अगर ये डिस्टेंस l पे होता, देन इट वुड बी द then it would have been an easy problem to do. मतलब easy मतलब अभी भी easy है, but understand कि cos theta sin theta का ध्यान रखना है, गलती मत करना। Is that clear?
जी सर। यस
Okay.
सर।
No, okay. Now let us consider the same problem, but a difference. Let us consider the same problem, but now instead of a point charge at q, instead of point charge q at a comma b, let us replace it by an infinite line of charge. So let us replace by n infinite lines of lambda, and let us keep it in a perpendicular direction. I'll keep it in parallel to x-axis, parallel to z-axis. So I'll use this kind of symbol. Okay, so this is outside the paper and this is inside the paper. Okay, so what I'll do, so same problem is there. So I have this infinite grounded conducting plane, I have another infinite grounded conducting plane orthogonal to each other, and instead of charge q I have this. If I'm doing this, I mean I'm writing that my line of charges parallel to z-axis. Okay, is that clear? And this is your x-axis and this is your y-axis. Is that clear?
यस सर।
Okay, and this is lambda. Okay, is that clear? So if this is lambda, then at point a comma b, so again you will have, because of this lambda you will have another चलो वो तो बाद में देखेंगे, पहले काम करते हैं, let us first find the potential at any point r from an infinite line of charge. So if you have an infinite line of charge, if I have, let's say, this infinite line of charge I'm having, this is having a charge density lambda, and if I want to find potential at a distance r, how to find it? Now the first question that arises here is, can we take infinity as a reference point for potential? Can we take infinity as the reference point in ascertaining potential? The answer is no. Why no? Because this is extending till infinity. This is a body that is extending till infinity. So if it is extended till infinity, I cannot take infinity as a potential a reference point, because at that point, at infinity also you're having some charge distribution which is going to contribute. So in any case, potential at infinity will not be zero because of this particular thing. So in these cases, we take let us consider any point r naught where your potential is zero. We consider that at any point r naught your potential is zero, and we keep this as a reference. Is that clear? And potential is given by what? Potential as a function of r is given by minus E dot dr from reference to the point r. You can place r dash here also if you get confused. ठीक है, समझ में आया? यहाँ usually infinity रखा जाता था, but because now we cannot take infinity as a reference point because this is extending till infinity. Is that clear?
यस सर।
Okay, so I'll use this term r naught. So potential as a function of r can be written as minus. Now again, you see electric field would be in this direction. And if you remember, this is, I think, lambda upon 2 pi epsilon naught r. This is the result that I think, if you remember. One can do it
यस
from Gauss law also and otherwise also. So lambda upon 2 pi epsilon naught r. And what would be the direction of dr? So the work done in bringing the charge particle from point r naught to, let's say, uh, from point r naught to, let's say, r. So dr is in this direction.
यस सर।
And if dr is in this direction, so I already told you that whenever dr is in this direction, your dr mod is written as minus dr, because you are coming in the direction by means of which you are decreasing. So only if you're If you have this, instead of increment, if you have decrement only, then you can move towards origin. Okay. And the distance between the angle between two is cos pi. So one cos pi would come because E is anti-parallel to dr. Another dr mod will become minus dr. So in any case, this will remain E dr from R0 to, let's say, R. Is that clear? And this you will get VR minus, and this is lambda upon 2 pi epsilon naught will come outside. This will be ln R from R0 to R0. You can write R dash also here. Okay. And now you can find what is potential as a function of R in general. It will be lambda upon 2 pi epsilon naught and ln of R0 upon R. And if you want to write in, if you want to make it in 4 pi epsilon naught only, so you can write square. Is that clear? Is that clear?
Yes sir. तो
Because
dr
usually
का नेगेटिव को कैंसिल नहीं करेगा?
देखो, एक dr का नेगेटिव आएगा और एक इलेक्ट्रिक फील्ड, क्योंकि इसके कॉस पाई है, तो इलेक्ट्रिक फील्ड का मॉड dr का मॉड और cos pi. So this cos pi will absorb this negative, and one negative will obviously remain here because this is work done by external force, by external agent. So work done by external agent will be negative of work done by the force. So this is how we do. Okay. 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 So now this is what I have derived so that हमको कहीं दिक्कत ना आए. Is that clear? Now I'll write the problem in more elaborate sense. So I think this was our case. Just give me a minute. There were two infinite line of there were two infinite grounded conducting planes, and we placed a infinite line of charge which is parallel to z-axis at point a comma b, and because of this there would be a minus lambda here at a comma minus b. There would be lambda here at a comma b, and there would be minus lambda here. This is something that we already discussed. Is that clear? ये चीज तो अभी हमने करी है थोड़ी देर पहले.
Yes sir.
Is that clear? And why I have done this? Why I have done this lambda upon 4 pi epsilon? Because देखो r square को maintain करना easy नहीं, तो r को फिर लिखोगे root over something, तो वैसे ही वो half आगे आने वाला है. And this is very arbitrary. This is arbitrary r0. So समझ रहे हो, तो मतलब r0 का square भी कर दोगे तो it is not going to matter, because let's say your r0 is 25. So here your r0 will become root over 25 का square. Is that clear? So this manipulation I don't think you'll be worried about.
Okay. Yes sir.
Okay. So now what one needs to find now, what is the problem statement like? We want to find, first thing that we want to find first thing that we want to find is, from this particular problem, my first thing that I want to find is potential as a function of x, y anywhere in the space. So we want, first thing I want to find, that I want to find potential as a function of x, y. That is, I want to find potential on the xy plane as a function of x, y on the xy plane. ठीक है, बात समझ में? Is that clear? Because is that clear or not clear?
Yes sir.
Okay. So what would be the potential? So potential as a function of x, y, let's say any arbitrary point x, y is given to me. It will be lambda upon 4 pi epsilon naught, I think ln, there would be some r0 ka square divided by x minus a ka square plus y minus b ka square. Is that clear? See, if at any general point I'm saying, let's say at any general point I'm saying x comma y, the distance would be x minus a ka square plus y minus b ka square.
Yes sir.
Is that clear? Okay. And I also want to find, because see, my conducting planes are in the xy plane only, so I want to find potential as a function of xy, because eventually I'm going to find induced charge density also on these planes. So induced charge density would be obviously as a function of xy only. Is that clear? So I'm
Yes.
interested in finding the potential as a function of xy. So this is one. Another one would be again lambda upon 4 pi epsilon naught, and because of this would be ln of r नॉट का स्क्वायर, दिस इज x माइनस ए का होल स्क्वायर। अच्छा सॉरी, ये नेगेटिव हो जाएगा। सो पहले एक बार पॉजिटिव पॉजिटिव पे लिख ही लेते हैं ना, एक बार लेट अस राइट फर्स्ट पॉजिटिव पॉजिटिव। सो दिस विल बी एट माइनस ए एंड माइनस बी, सो दिस विल बी, एक बार सारे पॉजिटिव पॉजिटिव मैंने लिख लिया। Okay, then there would be another two contributions that would be negative. This will be minus lambda upon 4 pi epsilon naught ln of r naught का square divided by x minus a का square plus y plus b का square minus lambda upon 4 pi epsilon naught ln of r naught का square x I think plus a का whole square and plus y minus b का whole square. Okay, is that clear?
Yes, sir.
Now let us एक बार काम करके देखते हैं, हम देखते हैं कि whether it is मतलब right or wrong also। मतलब देखो, one can understand कि because these are grounded, so I'll write एक बार चेक भी कर लेते हैं, since these are grounded, मतलब ये हालांकि यहाँ पे अभी मतलब तुम्हारे कंडक्टिंग प्लेन्स नहीं, मतलब इनफाइनाइट ग्राउंडेड कंडक्टिंग प्लेन्स नहीं है, since the boundary conditions, since the boundary condition require that potential here which I'm referring to and potential here which I'm referring to, potential along uh, x-axis and along y-axis must be zero, isn't it? Potential along x-axis and potential along y-axis must be zero. But ये boundary condition तो
Yes,
true
sir.
होनी चाहिए ना?
Yes, sir.
So let us verify that एक बार, इसके बाद verify भी कर लेते हैं. So एक बार check करें कि potential at x-axis मतलब क्या हो जाएगा, x, 0, y coordinate 0 होता है, तो यहाँ से देखें तो क्या आएगा, lambda upon 4 pi epsilon naught ln of r naught का square, and then you have this x minus a का whole square plus b square plus lambda upon 4 pi epsilon naught ln of r naught का square divided by x plus a का whole square plus b का square, then again minus lambda upon 4 pi epsilon naught ln of r naught का square divided by x minus a का whole square plus b square, and then again minus lambda upon 4 pi epsilon naught r naught का square x plus a का whole square plus b square. This would get cancelled, this would get cancelled. So potential at x-axis is zero, which should be the case. And similarly, by symmetry, you can find that potential on y-axis also should be zero. So ideally, whatever I'm writing is right, isn't it? Okay. And if I wanted to
Yes, sir.
find, if I wanted to find my potential as a function of x, y, z, then there is a problem because this is infinitely extending. So this is infinite extension now. Okay. So in that particular case, if I'm writing z as a function of z ना, तो मतलब जैसे कि इसको हवा में ले लेते हैं, let us take this at x, y, z. So मतलब समझ पा रहे हो मेरी बात? तो मतलब उस केस में z माइनस z का स्क्वायर हो जाएगा. Are you getting my point? Are you getting? मतलब देखो लैम्डा अपॉन ये था लैम्डा अपॉन 4 पाई एप्सिलॉन नॉट ln r नॉट का स्क्वायर अपॉन r स्क्वायर. तो r क्या होता है? इट इज x माइनस a का स्क्वायर प्लस y माइनस b का स्क्वायर और फिर z माइनस किसका स्क्वायर? z नॉट का. तो ये जो पॉइंट है, अगर ये हाइट में z डिस्टेंस पे होगा तो ये भी तो मतलब समझ पा रहे हो मेरी बात? इसके जो x और y कोऑर्डिनेट है वो तो a b होगा, इसका z कोऑर्डिनेट तो z ही हो जाएगा.
Yes, sir.
तो मतलब इवेंचुअली ये हमेशा एज अ फंक्शन ऑफ एक्स वाई ही रह जाएगा. मेरी बात समझ पा रहे हो मैं क्या कहने की कोशिश कर रहा हूँ? मतलब इसको समझने की कोशिश करना कि अगर ये मतलब इनफाइनाइट एक्सटेंशन है ना, जैसे इनफाइनाइटली एक्सटेंडिंग है, तो मतलब अगर इसको तुम इस पॉइंट को तुम एक्स वाई जेड पे भी ले जाओ, मतलब इसको हवा में ले लो, मतलब 3 डायमेंशन में, तो भी ये तो पॉइंट ए बी रहेगा. तो इसके डिस्टेंस एक्स माइनस ए का स्क्वायर और वाई माइनस बी का स्क्वायर रहेगा. और अगर ये हवा में है एट डिस्टेंस जेड, सो दिस इज ऑल्सो इनफाइनाइटली एक्सटेंडिंग. This is also infinitely extending. ठीक है, तो उसका जो डिस्टेंस रहेगा वो क्या आएगा? z माइनस z का स्क्वायर. सो eventually it will remain as a function of xy. This is what I want to convey. I think you should one needs to see, मतलब तुम्हें ये समझना होगा कि मतलब किस तरीके से मैं जो बोल रहा हूँ
यस सर।
समझ रहे हो, मतलब जैसे लेट अस से कैसे बोलूं ये चीज में कि जैसे मान लो
मतलब सर जेड डायरेक्शन में वो इनफाइनाइट एक्सटेंड कर रहा है,
हाँ
इसलिए वो पॉइंट भी वैरी उतना ही करेगा जेड में।
हाँ मतलब या फिर ऐसे समझने की कोशिश करो कि why probably I'm interested more on xy plane only because see at the end whenever you see the image problems now you are concerned about induced charge densities, you are concerned about what would be the total charge induced, okay, and this is like on xy plane. So one thing is very sure that I want to find potential as a function of xy. That is one motivation. So you can think of that in that way also. Is that clear? So ये चीज तो समझ में आ गया, and I've also made you realize that boundary conditions are intact. और अगर ऐसे समझ नहीं आता even as x tends to infinity and y tends to infinity, your total thing would become like यहाँ पे तो हालांकि दिक्कत ही आएगी because you cannot take infinity as a reference potential, because see infinity को reference लोगे तो क्या आ जाएगा, ln 0 आ जाएगा, तो again there will be a problem. Why there is a problem? Because we already know that my potential is not 0 at infinity. So that will become quite complicated to think. But at the excesses, one can clearly see that boundary conditions are met. Is that fine?
यस सर।
Okay. Now, if I want to find what is the induced charge density, so if I want to find what is the uh, induced charge density, so what was the algorithm like? Induced surface charge density. How you used to find? We used to find the electric field first. We used to find the electric field first. So let's say this is my plane. So this is along x-axis, and let's say this is along, sorry, this is along, let's say x-axis, and this is along, so this is along y-axis, and this is along x-axis. So electric field normal component would be along y, and electric field normal component would be along x. Is that clear?
यस सर।
So for this plane and this plane, I need to find what is my induced surface charge density. Okay, so electric field on this one would be what? I can write electric field normal component for the first case I'm writing would be equals to what? It will be again equal to sigma upon epsilon, but it will be minus del v upon del x. Is that clear?
यस सर।
Why del x? Because see the normal component, whenever we want to find the electric field, it is del v upon del n, where n is a normal component. So normal to this plane is x. So therefore I'm writing del v upon del x. And what at x equal to 0. Is that clear? On this particular axis, your x-axis, x coordinate is 0. Is that clear?
यस सर।
Okay. So yeah, I think now you can clearly differentiate. So derivative would come out as इसको differentiate करना भारी काम हो गया पहले. So try to differentiate it minus del v upon del x at x equal to 0. I'll straightway write the expression from the book. So at least तुम उस चीज को तुम खुद verify कर लेना 4 times. I think if I'm not wrong, अगर गलत नहीं लिख रहा हूँ मैं, then I think गलत नहीं होना चाहिए, नहीं तो फिर अपन दिक्कत आ जाएगी. I think there should be y here somewhere. Minus 4 lambda aby divided by pi epsilon naught y minus b का square plus a का square into y plus b का square plus a का square. Is that clear? And this entire thing should be equal to sigma upon epsilon. This is 1. And on 2, again, one wants to find electric field, and that electric field, the normal component, would be along the y direction. That will be minus del v upon del y. And on this axis, your y coordinate is 0. Is that clear? And again, it will be equal to sigma upon epsilon naught, and you will get, I think, 4 lambda ab, similar things, but x की जगह y आएगा, y की जगह x आ जाएगा. This will be pi epsilon naught. There would be negative over here. And this will be x minus a का whole square plus b square, and then there would be x plus a का whole square, and this is something I'm leaving to you to verify. Okay, is that clear? So this is your 2.
यस सर।
Is that clear?
यस सर।
Okay. If I want to find my total linear charge density, if I want to find, this is clear. This is from here we can get the induced surface charge density. From here I can get my induced surface charge density. Is that clear? ये चीज समझ में आ गई? So एक काम करते लिख ही लेते हैं. So induced surface charge density on first plane, it will be equals to what? It will be equals to minus 4 lambda AB, and I have y here divided by pi epsilon naught, and I will have y minus b ka square plus a ka square, and then multiplied by, again you have this y plus b ka whole square, and then plus b square. Is that clear? So this is your surface charge density on one, and what will be induced surface charge density on two? It will be minus 4 lambda AB x divided by pi epsilon naught. And this 2 is not square, understand the point. So this epsilon naught will go, so this epsilon naught I'm not writing, this will be this. This will be x minus a ka whole square plus b square, and then there would be x, sorry, not x, क्या था ये, x minus a था ना, x यहाँ पे आएगा x plus a का whole square plus b square. Is that clear? ये चीज समझ में आ गई? अब since there is a line of charge, so I will be interested in finding what is the total
charge.
linear charge density. हाँ, charge तो खुद भी हम सोच सकते हैं, that I'll come on later also, because if this charge q is placed here, if this charge q is placed, if this lambda is placed here, total, if, and let's say if it constitutes a charge q, then total charge minus q would be induced on, मतलब दोनों को सम करके करेंगे तो टोटल कितना आना चाहिए, माइनस क्यू या फिर माइनस लैम्डा. अगर ये लैम्डा है तो इसका और इसका टोटल इंड्यूस्ड, अगर मेरे को लीनियर चार्ज डेंसिटी निकालनी है तो कितनी आनी चाहिए, माइनस लैम्डा आनी चाहिए,
माइनस लैम्डा, यस,
है ना. ये तो हो गई टोटल इंड्यूस्ड सरफेस चार्ज डेंसिटी. एंड व्हाट इज द टोटल लीनियर चार्ज डेंसिटी इंड्यूस्ड? अगर ऐसा पूछे तो कैसे करें? सो ऑन द पहले एक बार करते हैं ऑन द एक्स एक्सिस. ऑन द एक्स एक्सिस मतलब क्या हो गया, y इक्वल टू जीरो प्लेन, y इक्वल टू जीरो प्लेन. सो अगर y इक्वल टू जीरो प्लेन कंसिडर करें तो y इक्वल टू जीरो प्लेन कौन सा था, ये था 2 वाला. Is that clear? Not clear?
यस सर, y इक्वल टू 0
है ना, y इक्वल टू जीरो प्लेन ये होगा, सॉरी y इक्वल टू जीरो मतलब y इक्वल टू जीरो तो एक्स एक्सिस यही तो होगा ना, y इक्वल टू जीरो इज एक्स एक्सिस होगा. ठीक है, एक काम करते हैं, लेट अस put this meeting because only 2 minutes are left. So I'll continue this in next session. Okay, I'll send you the link. So I'll continue there because this will not finish in 2 minutes. Okay.